Okay, welcome everyone to this month's core community call. This month we have Andrew giving a presentation on two SIMDs that he proposed in the past 2 weeks. It's relaxing transaction constraints and I think entry constraints. So Andrew, you can go ahead and take it away.
Right, I'm going to try and share my screen real quick. Sorry, I'm trying to figure out how to share just the, there we go. All right, can you all see that?
Yep.
All right, cool. So yeah, there's two SIMDs, 82 and 83, that deal with transaction and entry constraints, relaxation respectively. Mostly, I'm going to talk about 82, and if we've got time, I think we can get to 83, which is a lot simpler. I'm going to start off by giving some background and motivation for this work, and then I'll get into like the details of each of the SIMDs. So I started looking at this probably a couple months ago and realized that constraints on transactions aren't documented anywhere except the code. There's no like document that just says this is what a valid transaction is. And so that's something I've been working on. It's still not completed yet. But as I was going through that, I realized some of these aren't really necessary. There's a whole host of checks that we do to make sure that transactions can be executed. And these are transactions that could pay fees, and then we drop them very late in the processing pipeline when we could record them and take the fees from them, except that breaks consensus right now. So I started going through the process of what if we relax this constraint that transactions have to be executable, then we could potentially collect more fees if we do see these transactions. Of course, when I started relaxing constraints, that which constraints do we actually need when I was looking at the other constraints. As all of this is going on, we've been having ongoing discussions about asynchronous execution. And so that was noodling in the back of my mind as I was going through this exercise. And sort of background of async execution, there's two questions that we answer on the validator side of things, which is, does this block comply with all the constraints? If it does, then it can go into the history. And then this, the consensus side of things, which is, what's the result of this block? And then does the network agree with me? Async execution is just separating these two questions. But right now, because of the way that the constraints are built, they're very much tied together. You can't answer this first question, does the block comply with all constraints, without actually executing the block. So what's stopping us from separating these, at least logically? Right now, the SIMDs are not proposing that we go towards async execution. It's just moving towards separating these two questions logically, but not necessarily making them separated in time. The only thing that's stopping us is account state. On the transaction level, this consists of mainly 4 different checks.
And Andrew,
Oh,
so I think you're presenting the keynote, but I don't think it's actually going from each slide to slide, just as a heads up.
okay. Well, let me see how I can fix that.
I don't think it's showing the presentation mode when you're sharing just the keynote.
Gotcha.
We can just watch it like this.
Okay. Yeah, can you guys see if I like switch slides here?
Yes.
Yep.
Okay. I will not present. I don't know what I'm doing, I guess. So yeah, at the transaction level, this is 4 checks. Do the ALTs resolve account lookup tables? If the transaction is a nonce transaction, is the nonce account valid? Can the transaction pay the fees? And then can the transaction be executed? The last one's probably like 10 different checks rolled into one, but the summary of it is, can we execute this transaction? And SIMD 82 is the relaxation of 3 of these. So the nonce check, fee paying check, and executable check. The SIMD is not a proposal that we remove these checks for execution. All of these have to be met in order for the transaction to be executed. What it is saying is that if a transaction appears in a block, it does not, that breaks one of these constraints, it doesn't invalidate the entire block. We can either just not execute the transaction and take no fees, or we charge the leader a penalty for including that transaction. These transactions also will count fully towards the block limits as if they were executed with the maximum number of compute units. That just is there to prevent some denial of service attacks. I had 4 constraints on the last page, and I've only got 3 here. So I think a natural question is why leave in the ALT resolution? That's a temporary thing. It is still making us dependent on account state for the question of, is this block valid? But there are higher level constraints at the entry and block level that make removing this tricky at this time. So I'd like to remove that one at some later point. Additionally, ALT resolution is slightly different than the rest of these 3 constraints. The rest of these 3 constraints, the answer can change based on the execution of transactions within like the block that you're validating, whereas the ALTs are resolved at the beginning of the slot. Your view of them is essentially frozen when the slot begins. And so transactions within the block that you're validating can't change the ALT resolution. So that makes it so you can validate a block and just answer the question, does this block meet all of the constraints without executing the block, as long as you've executed previous blocks. I kind of already talked about these, and I'm just going to skip a slide and go to the benefits and drawbacks. So like I mentioned, this lets us validate the block, just say, does this block meet all of the constraints and can it go into history without actually executing the block? It also simplifies the protocol in some sense because now there are a lot fewer constraints on what can go into a block. We still have, obviously, to document like the executable checks, which is the most complicated part, but it separates that from what is a valid transaction and not. It gives a lot more freedom in block packing as well. I'm not suggesting that the labs client do this, but it enables something like a probabilistic fee cache where if I see some account has 500 SOL and they've had 10,000 recent transactions, all paying fees, maybe I just assume that they're going to pay their fees correctly and I just record their transactions without doing strict checks. Whereas with the strict constraint that all transactions have to pay fees, you can't do something like that. In terms of drawbacks, it's consensus breaking. It needs a feature gate. It's not a huge drawback, but just something to note. With the nonce check, it introduces the possibility that ancient nonce transactions, which are no longer in the status cache, could be repeated in the history if the leader isn't doing a good job. Now, we can still check that that nonce account is valid before execution, so the transaction would have no effect on state, but it introduces the possibility that we have duplicate transactions in the history. Depending on how we decide to do punishment for non-fee paying transactions, you could have transactions that pay no fees. And then on the SIMD, there have been discussions about potential denial of service attacks. I think the main thing on the SIMD that I missed and did not clarify was the fact that these transactions are still counting towards block limits as if they were executed with all of their compute units, which prevents a lot of the attacks that have been mentioned. The main thing I was hoping for input from you guys on is how should we handle these transactions that can't pay fees? Right now, there have been sort of 2 competing perspectives on how to handle these. One is that the leader is running an auction and they are selling you compute. If they fail to collect the fees, the punishment is that they don't get that reward. But there's also this perspective that when transactions pay fees, they are burning half of it. And that burning implicitly compensates the rest of the network for validating these transactions, which would lead to the idea that if we have these non-fee paying transactions, then the leader has to make up for it in some way by either paying those fees or paying some other fee associated with a bad transaction. Yeah, I think we can pause here and maybe open it up for questions and feedback. Is anyone totally opposed to this? What do you guys think about how we should handle these non-fee paying transactions? Yeah.
Go for it, Richie.
Yeah, I guess I'll start with, I think this is a great proposal. It puts us further into the direction of backlist leaders. I think the concern of possible DOS by not charging fees at all is a bit of a risk. I don't see that you would want to do this attack, but there is an attack where like a block producer could create a maximum size block that is just contains transactions that always fail. They cannot pay any fees, and
So this would only happen if it's a malicious leader, right?
yeah,
Because a normal leader is going to filter those. I kind of think that a possible mitigation would be to charge the leader the fees.
yeah, that's what I'm thinking too.
I
If the
don't-
leader
I-
doesn't
yeah,
have, yeah,
I had not written that in the original proposal, but since some discussion has been ongoing there, that is definitely where I'm leaning right now.
Then
I haven't changed the proposal because I wanted feedback on this call first. But yeah,
I don't think we can
continue.
take blocks by this attack, because if the block limits are enforced, like the compute limits and everything else, it's like kind of pretty benign to have a bunch of junk data. Like it's okay. Like execution should be faster, I hope, right? You like skip you should be able to fail those quickly in replay. So you're just wasted some of the bandwidth.
well, it's kind of annoying because it makes the DA layer of Solana, so to say, completely free. Anyone can use Turbine to distribute cluster-wide junk data, and nobody pays for it.
Well, no,
And
you have to have stake to do it. You have to be staked, right?
Oh, yeah, that's a good point. And you don't get any rewards if you don't have identity key balance to vote. So you would lose money if if you have zero balance, and we can't withdraw from the leader as a punishment if it has zero balance. But then the leader would lose out on the stake rewards, thereby punishing it. If we do charge a fee from the leader for these transactions, I mean, that seems like a very simple change to do, right?
Yeah, you'd need to there's a couple dependencies on that. For the leader to be in the leader schedule, their vote account would need to have a certain balance, right? That would be you would add the constraint there. So then
Yeah, but you wouldn't charge the vote account, you would charge the identity account, because this account also gets rewarded with transaction fees.
Yep.
Yeah, I did a quick calculation this morning of basically if the minimum number of slots you can get allocated in the leader schedule is 4. If they packed the smallest transactions they could, with assuming 1 signature, it'd be just under 1 SOL as a minimum balance. So I think there's already some ongoing changes to make 1 SOL the minimum balance. So I don't think we need to make any changes there. And effectively, if they were running an attack like this, it's sort of a self-solving problem because they get removed from the next leader schedule.
Why would they get removed?
If we take away their stake for punishment on these transactions, we charge them the fees.
Oh, okay. But isn't a mechanism that does this punishment a bit more complicated than just charging the fees? Or I might be misunderstanding.
I suppose what I'm saying is that the punishment is being charged those fees.
Oh yeah, awesome. Okay.
I think we're
Yeah,
saying the
that's
same thing.
Cool.
Another question, I guess, if we're leaning towards charging them fees, normally fees are paid 50% to them. What do you guys think that's reasonable, that they're just essentially paying half the fees, or should they be basically burning 100% of the fees as punishment?
Sounds like a bit of an implementation detail.
Yeah, I think that's we can figure that out later.
Okay, yeah, sounds good. But it sounds like everybody is leaning towards charging the leader fees for if these transactions don't, or sorry, either invalidate the nonce check or the fee paying check.
Yep.
Okay, cool.
It might be easier to charge the vote account. So like whatever implementation constraints, those would need to be kind of pushed to when the leader schedule is generated.
Gotcha. Yeah.
Sorry, if we want to charge the leader all of those fees and they get drained, let's say they get drained like at the beginning of an epoch and they still have a lot of leader slots.
That's why we will need to have like basically a balance check for their whatever constraint is to be in the leader schedule.
And that would be multiplied by the number of leader slots they have?
Yep.
Okay.
Yeah, that doesn't strictly prevent them from being drained, because there's really, to my knowledge, like there's no cap, no like reasonable cap on what fees could be charged. So like they could insert a bunch of like max priority transactions, which I don't think we want to enforce that they can have that many max priority transactions in a block.
But what does it matter if they're what priority they are?
Priority, it doesn't for execution. I'm just saying, like, if they inserted max priority transaction that can't pay fees, they have to have that. That introduces the possibility, even if we have like a minimum balance, they could still be drained.
Can you just like check before you start executing the block if they have sufficient like greater than whatever threshold balance, and then you just skip their block if they do, so if they drain it, then they're drained for one block?
You can't, it's really hard to adjust the leader schedule outside of the epoch boundary.
Yeah, you would just skip them, you wouldn't adjust. That's all, it would just be dead.
You can't have you don't have a guarantee that everyone that's observing the network is in the same state where they decided that leader should be skipped or not.
Yeah, I guess you would have to make it part of the like fork choice execution. So like when you start executing the block, do you think that they have fees? Yeah, I don't know, maybe it's more complicated.
Yeah, I think adding that check would sort of mean that we are adding another constraint that sort of prevents us from async execution, because you need to check the leader's balance before the block.
Yeah, good point.
Obviously dependent on previous blocks.
The draining doesn't need to cover the fees that you would expect as a network. It just needs to cover the cost, which in this case is just bandwidth, right? Like it's just enough of a deterrent that it's pointless to do it as a spam attack.
Yeah, that's a very good point.
Okay.
I would charge them
that makes sense.
Right?
proportional to the size and not charge them the actual fee that this transaction specifies.
Oh, gotcha. So you're basically saying don't charge them the fees, but charge them some separate penalty that's based on the size of the transaction.
Yeah.
Okay. That seems reasonable. It's sort of like an implementation detail.
The old Solana fees making a comeback.
So sorry, I want to come back to this because to me, I think what we should optimize for is still getting people's transactions in, like liveness #1. Like if someone can't pay for these extra transactions, but there are still valid transactions in that block, we should probably prioritize getting those executed, right?
I don't follow. Like, what do you mean?
Like if someone creates a block, some of the transactions are going to get rejected and they don't have enough to potentially pay for whatever egress fees we want to.
Yeah, the whole block should get executed. There's just like a cost to the leader to include junk, and to make sure that the leader can pay the cost, they need like a minimum sold balance at the start of the epoch in their vote account, or whatever account that's hard to withdraw during the epoch. That makes sense?
Yeah, okay. As long as we're optimizing that we can still get transactions in, that to me seems more important.
Well, it's like, it's gonna be like unlikely that somebody has like some valid transactions, but then is also doing a denial of service in the network unless there's a bug in the implementation.
Right. Yeah, I think the main concern with this is that you've got someone who's intentionally putting these transactions in a block rather than,
Yep.
or because of a bug, like Holly mentioned.
Does the SIMD include relaxing the entry constraints, or is that separate?
So that's what SIMD 83 is. We can move to that if nobody else has any more comments. All right. Yeah, this one's a lot shorter and a lot easier. Right now, entries can't contain conflicting transactions. That's not really too necessary. I think this is kind of lived on as like a legacy of the old implementation, as well as just it makes it easier to parallelize in the current labs code, but it's not strictly necessary. And this check also depends on us resolving the ALTs because we can't tell which transactions conflict with each other unless we look at the account lookup tables. So SIMD 83 just removes this constraint entirely and says you can put whatever transactions you want in any entry. This allows for more freedom in the block production. It also allows for more efficient networking. So right now, if I wanted to record like 5 or 10 transactions that conflict with each other, I have to put them in separate entries and those get sent out over Turbine individually. Whereas now, if they're in just a single entry, they can be shredded together and sent out as effectively one packet. And then, yeah, it gets us one step closer to async execution because now the entry constraints no longer have a dependence on account state. In terms of drawbacks, pretty minimal on this one. It's basically just that we need a feature gate. And I was talking to Steve yesterday, but I'm not even sure that this is possible. Right now, the way that the labs client does replay is we receive the entire entry and then we will process it. It might be technically possible where you receive like a partial entry and begin executing. I'm not 100% sure it is, but if that is possible, this SIMD would make that impossible because unless you receive the partial entries like in the order, you don't know that previous transactions in the entry don't conflict with them. So you sort of have to receive at least in order. But again, I'm not convinced that that's even possible with like the way that we deserialize these shreds into entries.
It's a cool idea. I think it's possible, knowing the layout.
I mean,
Yeah.
transactions aren't fixed size, right? So you have to like scan to find transaction boundary.
Yep.
Yeah, that was the part I wasn't sure about is like identifying if I receive like the 9th shred out of 10, I don't know how to identify where a transaction within that like arbitrary slice begins and ends.
Yeah, binning transactions to shreds, it's something that we talked about, but it doesn't really depend on removing this constraint, but I think that would be a totally separate thing. The benefit there is that you could do signature verification of the shred and the transaction totally in a separate pipeline, like as you're receiving shreds, but it's
Right.
that would be a
But
more
I
complex
think,
change.
right.
I'd love to see this constraint go because it kind of keeps the scheduler's hands tied behind its back, but there needs to be some upper boundary. Like for example, if like there are 2 types of clients, you know, I guess like finance and labs or whatever, and one of them consistently has a lower limit on the complexity of a graph that it can execute, it could somewhat split the network. And it's super easy to measure that because if you have a sequential dependency chain, so transactions that all write to the same account, and they all only load in the same small set of accounts, that can completely fit in cache and is pretty much CPU bound, because it's as fast as the VM can execute. If you have a lot of transactions writing to the same account, but all of them also reading a very wide set of accounts, then it becomes data bound, because you then have to wait for all of these accounts to arrive every single sequential dependency step. Liam, who can unfortunately not join the meeting for Zoom buggy reasons, has also done a lot of research into this scheduling, but I think we might need to come up with some mechanism to have some heuristic how expensive a block is going to be given some arbitrary graph.
Hey, can you guys hear me?
Oh, he's there.
Yeah.
Hey, Liam.
Hey, sorry, excuse the background noise. I'm in an airport right now. I was not able to join for a minute, but I was able to figure it out. Basically, yeah, we're working on something to actually help the network agree on what the actual cost of running a block is in real time. That's outside of the current CU model. We're still working on this, and I'm still passing the idea around and kind of workshopping it. But the basic idea is that blocks actually take some amount of time for the network to process as a whole. It's not just runtime. It's also network distribution time and all these other things. And there could be idiosyncratic reasons why, hey, a block takes a lot longer to send around as well as execute. So we're working on a proposal to address the issue of hey, this block takes a lot longer. Everybody's going to have to wait around and do this execution. So readers should probably have to, pay for that a little bit. Yeah, I think what you guys are talking about SIMD 82 and 83, correct? Yes,
Right.
I think I'm pretty happy with these proposals. I think my one big thing is that I'd love to just define what the new constraints, now that we're going to do this thing, what are the constraints on transactions? And I know that's a bit of an exploratory thing to have to do, but I'm happy to help figure out and spec out what those actually those new constraints now are on entries and on transactions.
Yep. Yeah. I will work next week on sort of rewriting some sections of the SIMD to be very explicit about what the new constraints are for both inclusion in a block and then for execution of a transaction. So I'm planning to do that. I just haven't done it quite yet.
Yep, that's okay. I think it's gonna take a while to kind of figure these all out.
Yeah. In terms of the cost modeling, I might have misunderstood what Richard was saying, but I don't think that's something new with removing the constraint on entries, right? Feasibly, I could just put those in separate entries and still create a block that's very expensive to execute, even if it complies with CU limits.
Yeah, maybe. I don't know the constraints on the entry counts, for example, too well.
Well, and another thing to think about, and I brought this up at the call with Andrew and a few others, which is that you have to think about an entry, or I may use the term microblock because that's what we call them at FireDancer, but we may call an entry you'll see an entry come over the network, right? And the entry is one packet coming over the network, and so sometimes they'll come very bursty, or you'll just see one of these, and you want to process, it's very easy and efficient to process individual packets, start executing individual packets of transactions. And so having this constraint that you can't have multiple writes there kind of slows us down fundamentally, because sometimes we are doing packet level processing at this point. So we have to be really careful about how many dependencies we introduce there.
And just being mindful of time because we are at time. Real quick, if anybody wants to continue discussing, you're welcome to stay, keep discussing. For anybody that wants to propose an agenda item for next month, you can propose on the core community call repository here. But yeah, if anybody has any other questions, go and ask. Otherwise, we can continue discussion in the SIMD and on Discord. Okay, thank you, Andrew, for presenting, and thank you everyone for coming for the discussion.
Thanks for giving me the time.
We'll see y'all next month.